find a room. For the morning one, we start about 10 minutes late just because of traffic, the rain, the parking.
Okay, not a problem.
We'll only do 5 minutes late this go around. I just want to introduce you.
Okay, sounds good.
So I'll do that real quick and I have to talk about a few administrative things. Go a little bit longer than the last CDC today. So no pressure.
I don't know. I would hit that bill.
Wow.
Yeah.
Oh, yeah. Yeah. We were putting the floor, right? I grew up in a rural area. Right. Yeah. Definitely a lot. But just opportunities I got.
So good afternoon, everybody. How's the show treating everybody? Good. Anything going on this year that you liked that you didn't see last year? Anything new, anything different? If you notice at the show this year, we have a lot of different things. We've got something for everybody. Some people like to go to the panels, some people like to come to the CECs, some people just like to come and go to the events afterwards, whatever, but we're trying to mix it up, being AFCEA Hawaii out here. If you have any ideas or feedback for us, or how to make the show better, we're definitely interested in learning from you all. Is this first AFCEA show in Hawaii for anybody? Right on? Wow, fantastic. Okay, and then how many of you guys are from Hawaii? Wow, okay, still about half, that's great. And I see some familiar faces from this morning session, that's great. My name is Mike Persay. I lived in Hawaii for 23 years. I've been with AFCEA, I don't know, maybe going on 35 years now, but not here in Hawaii, different places I've been stationed. I love what I do because the AHAF organization, AFCEA Hawaii Education Foundation, the money that we collect and the things that we do, we give scholarships to local kids in the local community. So last year we gave 26 scholarships, we raised $92,000. That had a significant impact to the local community. Over the last 4 years, we've raised $250,000. We gave out 105 scholarships, getting great impact to the local economy. We focus on STEM type majors, so engineers, math, that kind of stuff. But anyway, I love what I do because I see the kids' faces and the parents' faces when you give them that, scholarship. Nice. Okay, so this afternoon we have a real treat for you. We have Michael Sal, who's from Amazon Cloud Services. Let me read his bio here for you real quick.
You don't have to do that.
It's just a mandatory thing I do, Michael. So hold on. Is it Mike?
Michael, please.
Okay. Michael Sal. He is Amazon Web Services Principal Security Business Director for the Americas. Michael is a Navy veteran who served as CIO for Japan Forces in Yukon before retiring as a Navy captain after 26 years. Michael went on to become the Deputy CISO of Washington, D.C. before joining AWS in 2017. Without further ado, Michael.
Thank you. We'll have to find out who gave you that. So I didn't retire as a Navy captain. I was selected for commander, which was great. But I appreciate that. Thank you very much. So yeah, I'll take it. I'll take it, right? Just real quick, my understanding is there's a scanner in the back. So if you want CEU credit for this session, make sure you get scanned sometime during the session before you leave, okay? So I'm going to just cover really what is security in the cloud. one of the challenges we have in the cloud is that there's still a lot of people who really don't understand what the cloud really is. And of course, its name doesn't really lend the opportunity to really understand what it is just by its name, right? And of course, it doesn't really help that there's a lot of different, let's say, opinions or marketing out there of what the cloud is that can be kind of confusing. So I'm going to talk to you a little about what the cloud is, how does the security in the cloud work, cover some high-level benefits, and then towards the end, I'm going to talk about systems authorization in the cloud, how that can really work, and what's the realm of possible, because I know that's always a challenge. So before I get kicked off, as was said, so 25 years in the Navy, always with your traditional on-prem networks and data centers, right? So when I was in Europe, I was the operations officer managing all the Navy networks and telecom in Europe, and then of course, 7th Fleet, all the networks on the ship, and then CIO for Japan, again, all the base networks, right? So we call it one net for the Navy. In that time, my only experience with the cloud was, my personal Dropbox account, which was great, right? When I retired from the Navy, I went to the city of Washington, D.C., where I was the Deputy Chief Information Security Officer, or CISO, for the city. For Navy in here, you might have known the CISO, my boss, Captain Johnny Mack, or John McMichael, who was the CEO of Nick Tim's Pack out here before he retired. So we did some great things in D.C., but one of the first things that I came across in D.C. was the city was starting to move to the cloud. So one of the very first things that was moving was an application called the DC Healthcare Exchange, which was our implementation of the Affordable Care Act. Okay. Now coming in, trying to help John build the cybersecurity program for the city, we had some pretty good engineers, we had some pretty good tech, but we just really had no cybersecurity program for the city, believe it or not. Trying to build that, one of the first things was, okay, we got this cloud thing that we're starting to look at. And again, I really wasn't very familiar with the cloud. Now in the Navy, I tried not to be your no IAM, right? I will always try to say, yes, let's figure out how we can do it in accordance with the rules and securely. But when I got to DC, I will tell you, I was absolutely terrified of the cloud, right? My first job as a civilian, I knew I could get fired any day, and I was going to have to try to implement security in a realm that I had no clue about, okay? So I didn't really want to go look for a new job right away, and I couldn't really, honestly say no without some justification, some data to back me up. So I tasked my staff and I tasked myself to let's learn what the cloud really is, and can we do the same things we're doing now in pretty much the same way, right? Now looking back, that was a terrible task because I said do things the same way. And when you're looking at emerging technologies and innovation, you have to be open to doing things differently as long as you're meeting the same objectives. And that's been a theme from that point until now when I talk to customers, is really trying to help customers get out of very restrictive policies or legislation or regulation, and let's focus on security objectives. All right, let's figure out, there's so many different ways to meet an objective. Let's figure that out, on a case-by-case basis, and let's focus on implementing objectives as the goal. So it didn't take us long to figure out, yes, we could, right? So we might change a particular on-prem product or tool for a cloud service. Sometimes they're the same tools that can work in both locations. So it didn't really take us long to figure out, yes, we could. But then we started realizing there were some key benefits of the cloud that we had not anticipated. At the time, the best we had hoped for was the same, right? We never thought that we could actually get better in the cloud. So this started highlighting some key deficiencies on-prem that we've gotten used to over the decades. I think everybody has something in their life where it's not as good as it should be, but you just can't fix it, right? You don't have the money, it's too complex, you don't have the support. Whatever it may be, it's just not as good as it should be. And you get to the point where you just live with it, right? It just becomes the norm, all right? And this is what has happened a lot in our on-prem environments. And so what these challenges were, for me, that I kind of realized was a lack of visibility, a lack of resiliency, challenges with truly implementing defense in depth, and a low degree of automation. Okay? So I'm going to talk about these in a little bit more, but before I get started, these actually became benefits of using the cloud. So to kick off on visibility, this is something that there's an emotional reaction when you start talking about visibility on-prem. There's this paradigm that when you physically own something and you can touch it, you have greater visibility, right? And that may have been true to some extent in the past, where if you had 10 servers in a rack, there were 10 servers on the network. Today, each of those 10 physical servers could have 10 logical servers on them. So there could be 100 logical servers or virtual servers on the network. Well, how many should be on the network? 87, 43, or 100 if you max out your virtualized environment, okay? As we started adding network segmentation for traffic, endpoint protection, I can't tell you the number of times over my career where we would have a server kind of pop up out of the blue we had lost visibility of. All of a sudden we find it somehow, somebody's doing some scan, something, or they're playing around somewhere, and we find this server, like, wait a minute, what is this server? And we do some research, it's like, wait a minute, that server belongs to this program, it was managed by this team. Well, it has an old operating system on it, hasn't been patched. Oh, the sysadmin that was one left the command 2 years ago, all right? And we're like, well, okay, now we got to go figure out what happened, you know, trace it down, upgrade it, get it to where it needs to be, and bring it back online, all right? Meanwhile, for however long we lost visibility over, that was a huge vulnerability to our network, okay? And the other challenge with visibility is an on-prem environment. You have all these different technology platforms that are all fantastic platforms by themselves, right? They all have their own logging services, okay? But as you start looking across the spectrum of your network, each platform has different logging timing sources oftentimes. They're in different locations. They have different schemas. So when you're actually trying to correlate a security event across multiple platforms, it can be very challenging trying to trace something that goes between all the different platforms because the timing sources or the way the logs are, they're not really matched up very well. The schemas don't match up or align. When you're trying to bring logs into a log aggregator or your security information event management system, SIEM, not all of them make it, right? Your endpoint protection, if you're using, I think everybody here knows HBSS, right? Great product, but you'll notice that sometimes the endpoints are maybe not configured properly, or those reports or the logs don't get to your management server, okay? So we have these huge problems for visibility with an on-prem environment that we've been just living with over the years and trying to overcome as we identify a problem. So as we start moving to the cloud, now real quick caveat. I've tried to make this as agnostic as possible to AWS, okay? I have to highlight some things using some AWS services, but our competitors, our near competitors, have similar services. They may work a little bit different. There might be some pros and cons to each, but I'm trying to make this agnostic as possible, okay? So within the cloud, one thing that changes is everything changes to an API-based infrastructure, okay? So whether you log onto the web console, use command line interface, or use APIs natively, everything gets turned into an API, okay? So everything is API driven. Every interaction between a human machine or machine to machine, all right? Now it's also under this homogeneous underlying infrastructure, the schemas between the logs of the different services align and match. They have a single timing source, all right? So now you can start connecting all the dots more efficiently and more effectively across all the activity that's going on in your environment. So like the CloudTrail is that API logging service. Virtual private cloud is your security boundary around your application. I'm going to get into more of that later. But the flow logs is all that network traffic coming in and out of your environment. So you have the activity inside your environment and all the network traffic coming in and out, okay? CloudWatch is kind of like a SIEM in that it collects all these logs and it creates those events and alerts, okay? It's not as powerful as your on-prem SIEMs because it's not really truly a SIEM. But the thing that's so important with CloudWatch is it lays the foundation to start to automate your remediation, okay? And in security, automation is going to be key. You have your web application firewall, which is going to show you what's being denied or what's being allowed into your environment, okay? And then Inspector, which is a vulnerability scanning tool. So it's like similar to Nessus and Nexpose. And you can still use those third-party tools if you want to inside the cloud. You don't have to use the cloud-native version of it. Now these 5 are very similar to what you have in an on-prem environment, although I would argue that they're much more efficient and reliable and consistent for that to provide you that visibility, right? But what starts to change, again, from having that homogeneous underlying infrastructure, is now you can start having services automate the discovery and the review of your infrastructure for you, okay? So Trusted Advisor is a service that basically looks at your entire environment and is looking to see if you're following best practices. So today, if you have a particular firewall from a manufacturer and you want to know if you have it configured and operating in accordance with best practices, chances are you have to download a best practice guide and do a manual comparison between how you configured it to what the guide says, okay? Trusted Advisor looks at all the services that you're using and it tells you right off the bat, are you following best practices for security, right? So for example, we have a storage service called S3s, our simple storage service. It's an object store. By default, S3 storage is not open to the public internet, okay? So if you put a file in there, nobody from the internet can see it. However, there are times when you want to open storage to the public internet. You might have website content that's supporting a public-facing website, right? That's going to be open to the public internet. So you may open your storage to the public internet. As soon as you do that, Trusted Advisor will see that and let you know you have storage open to the public internet, all right? So it kind of gives you that alert. It's making sure that you're following best practices. If you don't have multi-factor authentication enabled for your privileged accounts, it will let you know that, okay? It also looks for cost optimization and performance. So if you are running, say, a genomics machine learning algorithm that takes 2 weeks to run clean on a standard compute instance, so this is your typical computer that you would see in your data center, and if it ever fails, you have to figure out what happened and rerun it, and then hopefully it makes it to the 2 weeks to finish, right? It will see that type of activity and look at it and say, you know, if you shift from a general compute instance type to a GPU instance type, which most organizations don't have in their data centers because they're extremely expensive, you can cut that 2-week run to 2 days or 2 hours, right? So now you're increasing your performance, and yes, something like that, the cost is going to go up while you're using it, but even then, because you're actually using it instead of for 2 weeks, you're only using it for 2 hours or 2 days, you still might actually save money, or it might break even, or it might cost a little bit more, but you're getting that performance. And the other thing that it does, it looks at cost efficiencies. So one of the challenges that our beginning customers have with moving to the cloud is when they kind of do the initial lift and shift, they will use the same size server or a little bit larger server in the cloud than what they have on-prem. Right? I'm going to talk a little bit more about what you can do for that, but typically in an on-prem environment, you are going to buy the largest, most expensive server that meets your peak usage demands, right? And it's going to sit in the data center, and whether it's being used at its peak or not, okay? So an example I like to use, although it's an extreme example, is say a university course registration application, okay? So if you are a university, 3 times a year you open up registration season for students. Thousands of students hit that web application, registering for courses, trying to figure it out, and then registration season closes, and then the rest of the year, it's just the admin staff updating the dates, the professors, and everything, right? Now, that's an extreme example, but even in the most routine applications, they go peak, say, Monday through Friday, normal business hours, and then at nighttime they go down. Or if you're a bank, does a bunch of batch processing at night, but it's not used that much during the day, whatever the case is, okay? So, going back to the on-prem, they have to buy the largest server they can to meet that peak usage, right? So as you start moving to the cloud, if you move that same large server into the cloud, okay, and it's not really being utilized peak consistently all the time, it will see that and it'll make the recommendation. If you go down to a smaller server instance type, you can save hundreds of dollars a month, thousands of dollars a month, whatever that is. All right, now I'm going to talk a little bit later about how you accommodate for that peak usage. All right. Then we have services like MACI. So MACI is like a data loss prevention or DLP service. Now, DLP usually sits at your perimeter and is looking for sensitive data that's leaving your network, right? So security numbers, credit card numbers, and hopefully it blocks it. Depending on what it is or who's sending it, they might allow it and send an alert. All right, but what about where that sensitive data is at rest? All right, who here uses shared drives? I don't know what yours looks like, but I can tell you what mine looked like in the Navy and in DC and just about everywhere else. They were a mess half the time, right? I think every 2 years we went through tried to do a big cleanup. So there's files. You could have Excel files with social security numbers or credit card numbers or just sensitive data all over the place. And it's always hard to tell who has access to it. Is it encrypted if it's supposed to be encrypted and all that kind of thing. So MACI actually scours your storage looking for where that sensitive data is at rest. And then if it detects sensitive data and you have rules in place, such as encrypt all credit card numbers, if it finds that Excel file with social security or credit card numbers, it will encrypt the file or the entire S3 bucket, depending on what you set it for. All right, so now you're starting to not only be able to get that detection, but you're automating the response. You're automating the implementation of security controls from that detection, right? It doesn't just send an email off to somebody and maybe they'll do it, maybe they won't, okay? It also has some limited user behavior analytics, UBA, okay? So if you have in your admin department that Excel file with social security numbers on it, and they only access it Monday through Friday, normal working hours, and then on the weekend at 2 o'clock in the morning, one of those accounts starts accessing it 500 times a minute, right? That's anomalous. That's not how they normally access that file. It'll trigger an alert, right? So chances are that account's been compromised. And you can automate the actions. Do you disable the account? Do you notify somebody? All of the above, okay? Artifact is not really a real service. It's a third-party, basically a document repository for all your third-party audit reports. So I can get up here today and tell you all the great things that we do for security and what you can do for security, but how do you know that we are doing what I say we are doing, right? This is your verify of the trust but verify. So you can download any of our third-party audit reports. It talks about the controls that were assessed, how they were assessed, and so forth, so you know exactly what you're inheriting and how well we're doing it, and that we're meeting your needs. And then lastly, GuardDuty is an intelligent threat detection service. GuardDuty brings in threat intel from Proofpoint, CrowdStrike, as well as threat intel that we developed from managing global infrastructure. Okay? This provides some context overlaid on top of all of the activity that it sees within your environment. So there are several state lists or signature-based threats that it can detect, and stateful or behavioral threats that it can detect. Everything from CNC activity, Tor activity, Bitcoin mining, all kinds of activity. Now, when you lay the threat intel on top of that, it tells you, okay, this is the attacker, or the source of this. It's coming from this IP address. It's coming from this country or this ISP. So now you know what might be a little bit more threatening to you. As soon as you stand up a web server on the internet, it's going to be scanned by everybody, right? And so now you know, okay, well, it's doing this type of malicious scan. It's coming from this source, a known cyber criminal. You can take a little bit, more priority action on that one. All right, so that's just kind of overview for visibility. So now I'm going to talk about resiliency. In my time in the Navy and in DC, resiliency was probably the thing that I worried about most, right? So within the security CIA triad, so confidentiality, integrity, and availability, we focus so much of our time and efforts on confidentiality and integrity, right? Privacy is all there, but availability is super expensive and it's super complex, okay? So even the most critical applications have a tendency to live on a single server stack in a single data center. If you lose a server or you lose a data center, you've lost that critical application, right? So if you have an application that's supporting warfighters downrange, that's not going to go over very well. But trying to load balance or trying to have an application that lives in multiple data centers at the same time, so if you lose a data center, if you lose a server, there's absolutely no impact to the warfighter. That's extremely expensive and very rarely done, okay? And so this was a big challenge. This is one of the things that when I started moving over, it was a benefit I hadn't expected that was absolutely critical to one of our reasons why we started really supporting the cloud. So to do this, we have to start understanding the infrastructure differences. There's kind of a misperception that the cloud is the new name or marketing for a colo, okay? So the colo facilities was somebody's data center, and they had their racks, and you just put your server in their data center, okay? It really, conceptually, was no different than you managing your own data center, okay? Everything for how you manage your server is pretty much the same, okay? What changes with the cloud, and again, I'm highlighting AWS-specific regions and things here, but our near competitors have very similar to this in many regards, although there's a couple key differences. So first at AWS, we have, actually, I apologize, it's an outdated slide. That's the problem with AWS. We always updating. All right, so there's 22 regions, and I think we're at 71 availability zones, and I think 130 edge locations right now. So we have GovCloud. We actually have both GovClouds now. And so the number in parentheses is the number of availability zones for each region. So what is a region? And so, oh, by the way, so for this audience, we actually have a secret region and a top secret region. So I think we're at 24 regions with that, and I think that's where the 71 availability zones come from. So I apologize for that misnumber there. So what is a region? This is really important to understand because even though there's cloud service providers and we use the word region, what a region is can differ between CSP. So this is something very important to understand. Some CSPs, a region may be one data center. So if they lose a data center, they lost the entire region. Maybe two data centers, one on the first floor, one on the second floor of the same building. They lose the building, guess what? They've still lost the entire region, okay? For AWS, our regions are divided into availability zones. An availability zone is a logical fault isolation zone, okay? This allows us to do maintenance on our infrastructure without impacting our customers. It also limits the impact of any service outages to within the availability zone, okay? Within an availability zone, there's at least one data center, but there are typically many more. And for the regions that you're going to be using within the US, there's many more than one data center within those AZs. Our data centers are physically separate facilities, okay? So if we lose a building, if we lose the power to a building, if something happens to whatever that physical facility is, we still have all the other data centers up and operating elsewhere, okay? Our data centers have more than one power provider, more than one internet connectivity, and so forth, okay? So what this does, this allows you, when you select a region, when you put your data into an AWS region, it stays in that region. We do not back up, copy, or move your data into any other region for any reason, okay? Because the way we built the infrastructure within our region, we can maintain our service level agreements to you to not lose your data within the infrastructure we have in region, okay? So our S3 storage service has 11 nines of durability. So that's 99.9 more nines % durability. That means we're not going to lose your data, okay, with a 99.99% availability. Without this, you would have to make sure that your data is being backed up somewhere else. Now, you can still choose to back up your data into any other region you want for that disaster recovery model, okay? But your data stays where you put it within AWS. All right. So within, for this audience, we have our US East and West, which can handle this type of data. Now, we'll say that I understand that DoD has slightly different meanings for stuff like FOUO and SBU and so forth. But as far as the US federal government goes, this type of data can go into our US East and West regions. So it's FedRAMP moderate and impact level 2, okay? Our GovCloud is your IL, your CUI, ITAR, CGIS, DoD impact level 4 and impact level 5, or any system categorized as high when you go to the systems categorization process. We have our secret region and we have our top secret region. Okay? So pretty much whatever level of classification or type of data you have, we have a region that you can put it in. Okay? We can support you. So whatever network you're on, we have that connectivity to that network. All right. Actually, one thing I want to clarify here. So GovCloud, I'm going to talk a bit more about GovCloud later on, but the one thing here to really understand, the main difference between GovCloud is GovCloud is staffed by U.S. citizens in the data centers and managing the services within those data centers. Oh, yes?
Is AWS thinking about putting an availability zone here in Hawaii? Maybe something for the Pacific because of latency to the...
So we've, I think it was already announced. I don't know if it's done yet. So we are building an edge location. So an edge location is a content delivery network. We also have our web application firewalls and our DNS routing all within that edge location. And so that's actually being built, and it might already be done. I don't know. Hayes, have you heard? It's in progress. It's in progress still? Okay. So that's still being done here within in Hawaii. But we also have hybrid capabilities, which I really don't have in this slide, but if you're interested, we actually have on our booth, we have a Snowball Edge, which is basically a tamper-proof encrypted mobile compute and storage device that you can take anywhere. So those are going on ships, those are going out in the field with the Army and the Marines and Air Force, going on planes to do all different kinds of missions. So we have that hybrid capability as well, which will help out. But we are always looking at growth. We're growing all the time, so who knows if we'll do more later.
And just to add real quick, what I would mention is there are applications that are running in AWS GovCloud today in this location. So the APAN team, the All Partner Access Network, is 100% deployed in AWS GovCloud today. EPAA also deployed in AWS GovCloud. And if you talk to those application owners and the end users, even all the way out at the tactical edge at the various places that they operate at, there is no appreciable difference in latency from what they experience today. So what you find is the DoD networks are really what drive the majority of latency from an end user experience perspective. When you get on the AWS network, we are lightning fast, 100 gig, private network that connects all of our global regions together. So from an end user perspective, you're going to see actually, in a lot of ways, better performance even operating here in Hawaii.
Yeah, that's a good point. So even though the geographic distance, which is going to have that physical latency, you still overcome the traditional bottleneck of the DoD data center, right, that is passing through. So even though you could maybe just go over a few miles away, oftentimes you still get better performance hitting our application in CONUS. So I'm going to talk. So that's great to understand our infrastructure, but what's really important is how do you take advantage of that to incorporate resiliency within your application, right? This is what's important, right? Because if you don't do this, all of our infrastructure is not going to help you if you have a single server crash, right? So this is how you're going to be able to start architecting for high availability and resiliency. So the graphic on the left is, say, a typical 3-tier web application, okay? So you have your firewall, which just represents whatever your perimeter security may be. You have a load balancer, which is a physical appliance. Hopefully you have at least 2, okay? You're going to have your web servers. You may have 1 or more app servers. Let's pretend there's 2 app servers here. If the second app server was to fail, the load balancers oftentimes won't know that. So they'll still keep sending traffic down this path. This app server failed, and there's going to be a timeout. So half your customers are not being serviced. Meanwhile, this app server on the left is up, so these customers are being serviced. Okay? You have a lot of single points of failure here from the physical data center, the perimeter, all the way through. Okay? You start moving to the cloud, you're going to select the region you want to operate in. You're going to create your virtual private cloud. Okay, so again, this is your security boundary around your application. I'm going to go into more of that later. You're going to select at least 2 availability zones. All right. Now, anybody who's ever done risk management, you know the power of 3, N+1. I highly recommend you select at least 3 availability zones. But for this purpose, we're going to go with 2. You're going to have your subnet still. But what changes here, instead of a physical load balancer, you're going to have this load balancing service. So these services are running on thousands of servers across all the physical data centers. So in the other load balancers, they're physical appliances in a data center. So this is what makes it a little bit more difficult when you're trying to load balance between data centers, right? So one's got to be a primary, one's a backup. They're always checking in. So if it doesn't report, then the other one, you have to reroute DNS. It's very complicated and can be very expensive. So now you have this load balancer service. So at any point, well, one is load balancing across, but if any point, if this server fails, it automatically redirects everything over into the other AZ. Now, even though I explained to you that there is a difference between an AZ and a data center, for architecting purposes, you're going to pretend they're the same. And so in this particular case, this is going to live somewhere in a physical data center, okay? But also, because you don't have this expensive appliance there, you're able to use that service pretty much anywhere within your application. So whether you just have it at these two tiers or even add one here and have it at all three tiers. So now, if this app server fails, again, all the traffic may be load balanced up here. Once this one fails, the traffic will come here and everything go back over to this server here. So zero impact to your customers. The warfighter sees nothing, right? They're able to do their mission no matter what. Actually, before I get there, the other thing, so a key thing here also, actually I'm going to add that. Sorry. We have these auto scaling groups. So another key advantage of the cloud is to be able to scale, okay? Now, when you're using a product like VMware on-prem, which is a great product, VMware has scaling capability, okay? Technically, it's there. But in order to scale, you have to have hardware for it to scale to. And rarely do we in the government actually buy extra servers that just sit there in a data center that you might scale out to, right? But now you don't actually have to buy any extra hardware to have it ready. That hardware is already in place. So let's go back to that course registration application, okay? Right now, what we've done, instead of having these very large, expensive servers over here, we have very small, inexpensive servers here, maybe costing you $50 a month, okay? As soon as you open up course registration season, either because you set a particular date and time, or because these servers the resources of these servers start being utilized to a certain point that you've set up for CPU, memory, and so forth, new servers will automatically spin up to take the load, okay? And you're only going to pay for those servers when they're up and running. As soon as registration season's over, you go back down to the core of the application, okay? So now, you're only paid for those servers when they're up and running. And this is what allows you to not only get that resiliency, that high availability, but it will actually cost less, right? So before, if you want it, it would cost more. So this is kind of counterintuitive that you're getting more capability and it actually costs less when you re-architect for this way. So two key points here. First of all, this is a self-healing architecture. Who here has ever been a sysadmin or is a sysadmin? Couple? All right, sysadmins, we treat our servers like pets. All right, I was a sysadmin on Windows NT 4.0, long time ago. We treat our servers like pets. We pet them, we feed them, we pray to the server gods. If a server dies, we cry. It is a bad day. Our boss is calling us, hey, when is it going to get fixed, right? There was one time I spent 36 hours to try to restore a server on a Navy ship. That was miserable. Right? The CO's calling down, the department head's calling down. It was a terrible time for me. Now, if one of these servers was to fail, as soon as it fails, this architecture detects that failure, kills the server off, and meanwhile, it redirects all the traffic to the other server, so there's no impact to mission, and spins up a new server to replace the failed server. Right? So depending on the OS, Linux or Windows, and what you put on it, between a minute to a couple of minutes, it's up and running. As soon as it checks in healthy, it's redistributed, load balancing again. Okay? So now, the sysadmin, it doesn't have to cry anymore, right? We didn't lose our pet over here, right? Who cares? We got a new one to replace it, okay? And so, at a higher level, this allows you to shift from a reactive disaster recovery risk model to a proactive resiliency risk model. All right, so that's very key. Not that you're going to get risk to zero, right? That's impossible. But you're able to mitigate a significant portion of that risk on the front end with less on the back end, right? Because we do not want to rely on our backups, right? Because those work out great every time, don't they? All right. So moving along, and then you can move to more managed services where you don't even have to manage the servers anymore, okay? So right now, in this particular model, this database down here, say it's a Microsoft SQL server, right? So you're managing the operating system, you're patching it, you're managing the SQL Server application and patching it, the database and data. That's a lot of work, right? It's what we call undifferentiated heavy lifting. Your DBAs that are doing all that kind of work, while it has to get done, does it really add value to your mission? No. What adds value to your mission? To be able to truly analyze your data, look at trends, and be able to make mission and business decisions based off of that data. So if you're able to shift to a managed service where we are now managing the operating system, patching it, we are managing the SQL Server application and patching it, your DBAs can focus on the data, making sure that the data is accurate, making sure you're analyzing the data, pulling those trends, and feeding that information to the mission and business owners so they can make more informed decisions, okay? All right, defense in depth. This is something that we've been talking about my entire career in the Navy, right? Decades. I'm sure there's a 1980s publication on it somewhere. This is reality. It's layer upon layer at the perimeter. Everything inside is soft and gooey. Right? Why? Because we have an open trust model. This is why phishing emails are so successful. Because why hit the perimeter that's hardened when I can just lob one phishing email in, the right person opens it up, and I'm everywhere, right? I've been in the data centers where every server in the data center can talk to every other server, even though there's no reason for them to, right? And so this is, when you look at what happened with WannaCry a couple of years ago, this is why it's so successful. We've got to get out of the open trust model and start moving towards a zero trust model. Now, we've called it a zero trust model, we called it defense in depth, but it's always been very difficult, all right? So I'm going to walk through how you can start achieving this within the cloud. All right, so first we're going to hit the perimeter. I'm going to go a little bit faster on this one because there's a lot of commonalities here. Okay, so first of all, your VPC, your security boundary again. Okay, by default, this has zero public internet access. So this application you put in here, nobody can touch it. It's useless, right? Nobody can get to it. Actually, before I get to that, you're going to add your access control lists. So that's like your stateless firewall capability around each of your subnets. You can add direct private fiber between your data centers and your CSP. Okay? So now you have this private fiber that you own directly from your facilities to your VPC. Okay? You can have a VPN gateway. So if you have remote users, they can VPN into here. So right now, this could be an internal application just for your organization. Right? Again, no public internet access. If you do want public internet access, you would add an internet gateway. Now people can actually get to it from the public internet. Okay? Say if it's a public-facing website. By default, everybody gets free DDoS protection from AWS Shield. Okay? Now, we have a paid service, Shield Advanced, that provides a timed human SLA response time, some cost protections, and so forth. But by default, everybody gets free DDoS protection, which you're paying for now on-prem, right? You have a web application firewall, and we have the largest ecosystem of security partners. So chances are, whatever you're using on-prem, if you want to extend that into the cloud, and same with our competitors, they have a lot of the same partnerships. You can do that. Okay, so now you can still have, say you have F5, you can have your F5 engineer have that single pane of glass managing on-prem and cloud at the same time. So that helps with some of the retraining. It helps to make sure you're still, meeting your objectives as you're migrating to the cloud. And then we have the GuardDuty, that intelligent threat detection service. All right, so this is still pretty similar to what you see on-prem today, right? Yes, sir. So that's where you would have, say, privately leased fiber.
The whole fiber band like this would do, or just say one wavelength
That's a good question. I don't know the answer to that. I think we have both, depending on who the vendor is we go through. But if you want to stop by our booth afterwards, we can make sure you get that answer. Okay, thank you. Yes, sir. Yes. So this is where things start to change, though. All right. So again, when I talked about the data center, where every application server can talk to each other, by default now, you're going to have this security boundary around every application. Okay? There is no communications between your VPCs. So even if you're the owner of them, it's in your account, the VPC doesn't allow communications between those. So if there was a compromise in one, they're not going to let move over to the other. Okay? You can reduce the scope of impact. Now, if you want to, if you have a need, you can build communication paths between them. Everything from, say, a VPN over the internet, maybe a layer 7 communications. You can have a private link. So it says one-way secure communications. It's really two-way, but it can only be initiated by one. This is if you have a microservices architecture. Okay, you might call it a general services, a GSS, general support service. Applications that are supporting multiple, right? Or you can have VPC peering. So this is really private networking connection between your VPCs. All right. So, but this is where, in my mind, we really start getting into a real good defense in depth within an application. Okay. So we already know that within the data center, it's all open. It's definitely open within an application, right? Because all the servers in an application trust each other. Now, we still have those subnets, so you have that stateless firewall capability with the ACLs. But now we're going to add these security groups, which are stateful firewall capabilities at each tier, between each tier. Right? So on-prem, if you wanted to get this level of security, either between applications or within an application, you'd have to buy your firewall appliances, and those are extremely expensive. Right? So these are free services that you're going to configure. So it has that stateful firewall capability. So you have stateless and stateful firewall capability between the tiers. Because a web server should never be talking directly to the database server. If that's happening, the web server has been compromised, they're going straight after the data. Right? Now you can ensure that the security of the servers and the networking follow the business logic of the application. Right? Only the proper connections, ports and protocols, everything is going through. Also, whether or not the authentication. You could actually have them require to authenticate between each other. Okay? So it's not just core networking. Okay, well, I can see this IP address. I'm using this port and protocol, therefore I have connectivity. It's not just that. I have to authenticate. This server has to authenticate to the other server every single time. Right? So you're ensuring that security within your environment. Also, we talked about with auto-scaling, servers can spin up to take the load. The security groups allow it so that there's no communications by default between servers within that security group. So as you scale out and add more servers, they cannot talk to the others in the same tier by default. You can allow it if you need to, all right? But by default, it's secure. You can still add whatever third-party endpoint protection, in this case, HBSS, right? You can still scan your servers for patches or vulnerabilities, right? We have Systems Manager, which keeps the inventory of your servers regardless of OS, what network they're on, and the patching, and can send patches to them. You have all your logging within your environment, and you still have that intelligent threat detection going on. So now, as you saw, you're able to implement pretty much the same security perimeter, but now you have it around every single application, between the tiers of the same application, and between the servers of the same tier. Okay? And the only layer next to this, which I don't have a slide for, is the data layer. Right? And that comes down to one thing, encryption. Encryption at rest, encryption in transit. Right? And we have FIPS 140-2 validated hardware, level 3 and level 2, and of course all the algorithms that are compliant algorithms. All right, automation. This was one of the other really big benefits that we found in DC for security in the cloud. So we were building a security operations center, or a SOC. We didn't have it fully staffed. It was very, very difficult to find people, and DC is one of the areas that have probably the biggest pool of cyber talent. And of course, they're also very expensive. So we're building out our SOC. We have some people. We're still looking for more. We're building out our processes. We came to realize that it's like we're never going to get ahead. We're never even going to get caught up. All right. So this is one of the things we were not expecting to find as a benefit to the cloud. So first thing with automation is remove humans from the data. Right? Remove humans from the processes. Okay. Humans are best to make judgment calls, judgment decisions. They are not best to take repetitive actions over and over again. Okay. So I talked about GuardDuty quite a bit earlier. So these are everything in white are the signature-based or stateless threats that it can detect, and everything in blue is your behavioral or stateful threats that it can detect. So one example, we had a commercial customer that was running Microsoft Exchange Server in AWS. Exchange servers always run hot. There's people always sending emails, so they always run at a high utilization rate. The company had some employees that thought they were going to make some extra money, and they installed Bitcoin mining software on Exchange servers, thinking the Exchange server activity was going to cover up the Bitcoin mining activity. And it did. Nobody caught it. Nobody saw it. Until we released GuardDuty, they turned it on, and then within a couple of minutes, it was picked up, detected. Because of the logging, the company knew exactly who did it and when, so they were able to deal with that organizationally. But they also knew exactly where it was, and they were able to clean that up. Okay. One example that I like to use, now this is a really simplistic example, but I hit on it earlier. As soon as you spin up a web server, it's being scanned by everybody. Right? Google's scanning it to add to search engines. Cyber criminals are scanning it. In your particular case, nation states are probably scanning your servers. How do you know which scans are the most risky to your organization? Okay? Today, you're going to get a bunch of logs and alerts, and you're going to have a security analyst sitting there watching them and trying to figure out which one to take action on. They're going to have to do the research, figure out what to do, take the action. At best, 30 minutes is going to go by before something's done for something simple that they know. Realistically, it's going to be hours, days, weeks, or months. Right? The last study I saw, it was something like 280 days was the average time it took for an organization to detect a breach. Almost a year before somebody detected a breach. Okay? So now, what we do is, so all this is great, right? All the detection in the world between this tool and other tools that are out there are fantastic. But if you are not automating the response, you're going to basically, I'd say you're going to fail. All right? You're going to get breached. You're going to get hit. So in this particular case, GuardDuty detects the malicious scan. That threat intelligence that I talked about, the IP, this knows it's from a particular country. Say it's a known nation state APT actor. Okay? It creates that event. Lambda is a serverless function service. So think of little snippets of code or little functions that you've created waiting for something to trigger them. In this particular case, you have an event. You can call it, nation state malicious scan. As soon as Lambda sees that event, it's going to trigger the function that you created. In this particular case, the function is going to take that IP address of the attacker and add it to your web application firewall filtering rule. So now within seconds to minutes, you have stopped the scan before they've been able to detect any vulnerabilities. Even if they were able to detect a vulnerability in the first couple of seconds, they can't go back and exploit it. And it's protected against all the servers that are behind the WAF. Okay? So now you don't have to worry about a human trying to catch up with this. Right? It's protected. Now, if you need to add a human stop gate, say this is something not quite as simplistic, but you need a human to look at what's been detected and actually make a decision of what to do, you can add a human stop gate in somewhere. So you can have everything built up, and then your security analyst presented with choices. Do I add it to the WAF? Do I add it to the firewall? Do I send an email? Do I ignore it? Right? Maybe if you're doing some type of counterintelligence, you want to allow it for some time. Send off the right notifications, turn on some other tools to start monitoring it, so you get some counter collections on it before you stop it. Right? So you can add those human stop gates. And then, of course, you can add it to, like I said, other third-party products, communications channels, and so forth. But here's the thing. don't just automate the remediation, the technical remediation. Automate everything. Automate the notifications. Automate the update of the documentation. One of the challenges I always saw in security operations was every time somebody made a change to mitigate a threat, that change was rarely reflected back into your configuration change management database. Right? So now your source of truth is false. Somebody might get an email, and they may or may not update it, right? But now, through APIs, update your configuration change management database. Update your SSP. So the next time you're going for your ATO, guess what? Your documentation is updated. You're not going through 500 pages manually trying to figure out what changed or what didn't, right? Update all of that automatically. So these are just a lot of our security services. The one thing I want to highlight here is in the on-prem, you start at the perimeter. You build your perimeter, and then you build everything inside. Okay? In the cloud, you actually start with identity and access management. That's your starting point. You secure your identity and access management, then you turn on detection services, and then you start building out from there. Okay? So a little bit different approach. All right, so from here, I'm going to shift to, okay, well, I guess not this one. So one thing that we see a lot is customers have a tendency to start with something non-sensitive, like a public-facing web page, something not that critical, but they don't bring in the security team or department, or in your case, maybe CSSP, right, your cybersecurity service provider. And then what happens is, okay, fine, but as the organization grows and they start doing more and more in the cloud, at some point they're going to get to mission-critical applications. And then you're like, oh, we got to let the security team know. Well, guess what? A couple things. First, the security people are probably going to be upset that they were not brought in earlier, and now you have some political rife internally, so it's not just overcoming some security concerns. You have to overcome these emotional political turmoil. But they also didn't get a chance to grow and learn with the rest of the organization so that they can be ready for the mission-critical applications. So if you're contemplating moving to the cloud, if you're working on it now, please make sure your security team is part of that initial discussion. Yes, I understand that sometimes roadblocks go up. They can be difficult at times, but it's much better to deal with that in the front end before the emotions kick in on the back end, okay? And we'll be there to help you with that. I thought this was a good quote, right? We're talking literal rocket scientists, right? And they feel that they could get better security within the cloud than what they could provide on-prem. So now I'm going to shift gears a little bit and talk about the systems authorization process a little bit. What is FedRAMP? So if you're not familiar with what FedRAMP is and how you can leverage the cloud for your RMF process to get your ATOs, I'm going to talk about that a little bit. And I'm also going to go a little bit kind of the realm of possible, which probably nobody in this room is ready for yet, but just kind of a key keep in mind. So first of all is to understand kind of like the FedRAMP process and what we go through. So there's hundreds of CSPs, right? And this includes your infrastructure as a service providers, your platform as a service providers, and software as a service providers. Okay. Now, I'm not going to get into exactly what that means. There's different opinions on that, but just say, all these cloud service providers are out there. So we're just one of many. As we start going through the FedRAMP process for FedRAMP moderate, all right, there are about 30 or about 20, actually I think there's more than that, about maybe closer to 30 CSPs now for moderate. There's 325 NIST controls that you inherit, that we implement within our infrastructure that you inherit, okay? So that's 325 controls that you don't have to implement, you don't have to monitor, you don't have to prove. Okay? This is one of my favorite things. I know you can't read it, reciprocity. I love this word. Nobody else does. This is the one place where reciprocity works. I don't know how we got that to work. But as soon as we get our FedRAMP moderate authorization, we automatically get the DoD Impact Level 2 authorization. Okay? I wish we could do more reciprocity. We need more trust within the government to trust the government. So this is for FedRAMP moderate. All right, so this is in our commercial regions, U.S. East and West. Okay. As we start moving to FedRAMP high, we add 96 additional controls. Okay. And right now, there's only 3 cloud service providers that meet FedRAMP High. So that's 421 controls for FedRAMP High. For DoD Impact Level 2, we add an additional, level 4, we add an additional 38 controls. Okay? And for Impact Level 5, we add an additional 47 to the 421. So now, you are inheriting all of these controls at that level. Okay? There's something like 800-something controls within 853. And I think you know that you don't actually have to implement every single control. They're not all applicable to you. All right? But right off the bat, you are inheriting, what, 468 controls. And this is within our GovCloud region. 468 controls. That's a lot of work that people used to have to do. All right, so what does this mean? So all that's provided by the cloud service provider. So now I'm going to walk through kind of how things are going. They're not there yet, so it starts to go into the realm of possible. All right, so we have our cloud service controls, right? So we have R3 for Impact Level 2, 4, and 5. And there are EMAS packages. I'll share that, although there's a problem with that right now. Yes, sir?
Impact Level 6, how far are y'all from that?
So we have Impact Level 6. That's in our secret region. So that's already set. The challenge we have with our Impact Level 6 right now is Impact Level 6 in our secret region. The intelligence community paid for our secret region. And so it's really some contractual challenges between Title 50, Title 10, all that good stuff for the DoD to get in there. So we have a PATO for dev test in IL6 right now for the DoD. We're working with DISA to try to get so production can go in there. Now, Transcom is doing a lot of work trying to get into our secret region for IL6. So I think they're in there for dev test right now. They're really pushing for the production. Good answer your question? Okay. So then you'll be able to inherit any type of joint or cross-service controls. So DISA has the CAP or now SCCA. So if you're going through that, those are additional controls that you'll be able to inherit, right? There's a package for that. There's an ATO for that, okay? Now, your service, this is where we're kind of exploring with the different services, or if you're from one of the COCOMs, some possible opportunities here, okay? So in this case, I have the Air Force. Couple things. Supply chain risk management has kind of become a bigger thing these days, right? It's been added to the NIST Cybersecurity Framework. You're seeing a lot more in different places. So one of the areas is your DevOps process or your development process, okay? The architectural environment that you're developing in, the tools, the controls you put in place there. If you're able to ATO that environment and those processes, those are controls then that the end application can inherit, primarily on the supply chain risk management and some of the other controls that you're able to inherit. Okay, you have your CSSP. So in the Navy, I know it's NCDOC, and I apologize, I don't know what all the other services the CSSPs are called. But you have a cybersecurity service provider that's monitoring your environment, letting you know when they see malicious activity and helping you coordinate it. So there's some controls you can inherit from them. The other thing is, and this is kind of a paradigm shift, is today's on-prem environment. If you go from ship to ship, base to base, even though they're under the same program and they should be technically the same, they're not. Okay, and every time you have a new program of record and they're going to develop some new application, that application is going to go live in a data center. They're going to inherit everything in that data center, right? But the problem with that is, again, it's all open. As you start moving to this, you're able to basically ATO a basic infrastructure, all right, for an application. So in the cloud, everything is infrastructure as code, okay? So you don't actually have to buy the hardware anymore. You don't have to go manually configure it or maybe run some install scripts. Everything is code. So when you build out an architecture, say you build out a basic architecture for Impact Level 4 data, or maybe HIPAA if you're supporting a hospital, or whatever it may be, okay, you can then save that entire architecture, the applications, the images, as a template, okay? So now if you get an ATO on that template, every time there's a new program of record, if they're going to say, okay, I have a new program of record, it has to be IL4, it's going to be at the IL4 level, or it's going to be HIPAA, I'm going to initiate that program of record using the approved ATO'd architecture. There's built-in controls automatically there. Okay? So now, once you do that, you're inheriting all these controls, and all you have for your application is basically what is actually sitting on the servers themselves, right? If you're patching the OS, if you install something on that server, or whatever it is you've actually done, that's all that's left for you to actually ATO, okay? So now you're inheriting maybe 500, 600 controls, and there might be 20 to 100 at most probably, depending on how you do it, controls that you actually have to implement and monitor within your environment. That also means that continuous monitoring that you have to do, there's less monitoring that you have to do. More likely that you're going to find some, be able to find and respond to something when you're only monitoring a few things than when you're monitoring everything, right? So kind of taking this to the next step of the realm of possible, I'm going to skip this. Actually, no, I skipped that. Is the ability to start kind of updating deployed units this way. So on the left, you can do all your dev test and staging within the cloud, okay? And when some of those hybrid capabilities that I talked about, you can see at our booth, that's now being deployed on ships and in the field, you can send everything, all your updates over as code, all right? So now in the old days, if you had to update some software, it's usually like 300, 500 meg exe file, right? You have to download this massive file. Now, it's a text file, right? A few hundred KB text file, maybe a meg or two, depending how big it is. And it's just code. So now, for those deployed units that doesn't have a lot of bandwidth, they're getting all their updates as code coming over here. Now, I picked USS Higgins because that was my first ship when I was commissioned. So and if you don't know, Admiral Mike Gilday, he was my CO on the Nimitz. So it's great to see him as a CNO now. So it goes out to the ship. Now the other thing is, what happens though is how does the Program of Record Office know that a deployed unit actually updated, right? Oh, they send off an email or they log on to some web page and say, yes, I did it, okay? With this, we can actually start using digital clones as well, and the unit can send basically a very small text file, whether it was updated, whether it failed, or even to where it failed, if there was multiple parts, okay? So the challenge is, so I apologize, I'm always defaulting back to Navy. So SPAWAR, actually, what's it called? Is it NAVWIC? What's the new name? No, SPAWAR, not NAVFOR. NAVFOR? Is that what it is? Oh, I apologize. All these name changes. Same job. So one of the challenges they have is that they have a program of record. They know what is supposed to be on every DDG, right? The reality is it changes, right? The sailors make changes based off of, things break, they got to respond, they got to get the system up. Some updates take, some don't, right? So instead of having that one dev test environment that pushes out to the entire fleet, you can actually have a digital clone. So what you'd have is you'd have this architecture up that mirrors every single ship in the Navy, right? Or every single field activity or talk in the other services. Now, you wouldn't have it up and operating all the time because you don't want to waste that money. But what you do is, if you have from the big program of record, right? You do your dev test, you stage it and do a last test on the digital clone. Everything checks out. The digital clone pushes it to the deployed unit. It updates. It sends back an update validation. When this is checked in, then it commits all the changes in the digital clone. As soon as they're committed, the digital clone shuts down. You're not paying for those services anymore, okay? So now, if there's, when a ship or a deployed unit has a major problem and they're calling back for help, they don't necessarily have to go into the ship and say, well, log in here, what do you see? What's the error code? They can go straight into the digital clone and see exactly what's on that deployed unit, okay? So a lot of this is kind of, again, the realm of possible. This is not happening anytime soon. You might hear it, Admiral Barrett talks about compile to combat. You might have heard ATO in a day. There's a lot of different things out there. But the concept is there. The technical capability is there. It's really about adjusting the policies, procedures, getting people on board, understanding it to kind of start implementing that to some extent. So these are our EMAS packages. All right. Any DISA in the room? All right. If you have any pull, I would love your help. So these packages are in EMAS. They are authorized. They are approved. EMAS says they are not. So that's a big challenge for us. And these are the SCCA EMAS packages. But this does have all the controls and everything you can pull in. It is there. We do have the authorizations. We can prove it to you. We can walk you through it. It's just the EMAS application, they won't help us click a check box there. So if you have any questions on that, but these are the numbers so you can pull into your packages. So my personal experience, and we see a lot of customers, is the cloud is not just as secure, but you can actually achieve greater security and more confidence in your compliance within the cloud. You have greater visibility, more resiliency. You can really truly implement that defense in depth, and you can automate your responses so that you're keeping up with the speed of a cyber, if you will. The one last thing I want to end with here is we have a program called AWS Educate. This is free for students or veterans. If you Google AWS Educate for Veterans, you can sign up. You will get free AWS training online, as well as free credits to use our services so that you can play around with them while you're learning. Okay? And of course, we have the job board on there. But if you're a veteran, make sure you Google AWS Educate for Veterans. If you leave out for veterans, it's going to come up with the education piece, and you're going to try to figure out, well, where do I sign up as a veteran? But if you have an EDU account, or if you have children, actually, I think the age has to be 14 or above. They can sign up. So like your middle schoolers, high schoolers, college students are going to sign up for this as well. And with that, that's all I've got. Thank you very much for your time. Any questions? Yes, sir. Okay. Oh. Yeah. Yes, sir.
A super quick one. Is this presentation available?
I will provide it to AFCEA, so you guys can get, I don't know how they're going to distribute it, but I can provide it.
So just, the idea is you want to have good best practices to, when you deploy a cloud environment, to secure it. And then we have lots of cyber tools, and I'm going to get through this here. Here's an example of GuardDuty. So over in AWS, there's a tool called GuardDuty. It basically scans your environment for any attacks and reports on it, with very, very minimal implementation. So, you don't have to deploy another IDS or, you had a question? Okay, sorry. It's also funny, like, I basically spooled up a server, and within like 30 minutes, I had adversaries trying to attack it. I think the important thing to note is, there's some of these ranges of IP address and entries are known, and there's a lot of things scanning these environments. So it's important to secure these environments. But the cool thing is it helps you easily basically identify kind of high findings. The second piece is there's a tool called AWS Macy. Macy provides the ability to kind of scan for sensitive data. So in the last couple of years, you probably saw there's a lot of newsworthy articles around S3 buckets getting compromised. So AWS rolled out a cool service for you to help identify what data is within your environment. So if you have PII or maybe credit card numbers, there's some things you can alert on. So here's an example, and here's some common indicators that they have. Is there credential loss or open permissions? I want to know the first thing that they did is probably let you know you had public S3 buckets. The other thing is, like Azure came out with something called a Security Center. So it was a way for them to kind of centralize a lot of the policy and technical controls around implementations of the CSPs. And I can show you that. So here's an example of just kind of all the things that you have access to that you can go through. And then like even OpenSCAP is good. I don't know if you've used that. A lot of it is around how do we do compliance and scoring around some of our operating system assets. And some of the CSPs are slowly actually building a lot of these STIGs within their AMI images. And I'll show you some of that. A lot of times we also are trying to drive this kind of zero trust strategy. So there's some other providers out there like Duo and Okta where they're integrating with these CSPs and providing the authentication access. So how do we actually look at behavioral health? So a good example, you check your enterprise email today. Well, is someone validating that your iPhone is the latest version? You patched it? Is it encrypted? I'm big on kind of behavioral health of your devices. And a lot of times, we'll use something like Splunk or Elastic to ingest a lot of the CSP data within a centralized location. One of the good things about using Splunk is they have actually an AWS connector or an Azure connector, which will actually pull the CloudWatch logs and stuff into a centralized location. So when you're managing multiple mission owners, multiple CSPs, having a tool like that is very important. And then we do a lot of auditing around 800-53 controls. So the more that we can automate this amongst mission owners, the better. So if you're using ACAS, ACAS is a really good tool to do that. AWS has their security hub. It's funny, one's called AWS Security Hub. The other one is Azure Security Center. Half of my time I spend learning the differences between AWS and Azure and Oracle, for my Oracle folks back there. And kind of how those things translate. And then back to Azure Security Center, they really give you a good synopsis of okay, what are you for policy compliance? What is your security hygiene? And I mean, there's a lot of good things that you can do analysis from. All right, I'm almost through the slides here. So. Lastly, I want to talk about some of the DoD use cases here. So if you're not familiar, one of the programs that we help build and operate is MilCloud 2.0, and there's some really cool reasons for using this. Let me move to here. And this is all on the MilCloud 2.0 website as part of DISA. So. One of the benefits of using this cloud provider, it's IL5, it's within a DISA deck. You can MIPR funds to it. You can pay as you go. One of the other cool programs that we help support is the U.S. Navy for their cloud brokerage. So we're doing some cool things there. Navy, we're helping build an SCCA stack. We're doing some cool stuff with them. And then for the Air Force, we're helping them with some of their DevSecOps components. So this is all on the DoD website as part of their enterprise cloud strategy that I pulled from their strategy document. But they're doing some cool stuff with how they're driving containers to help improve the cybersecurity components. So notice, this is kind of the DevSecOps approach to how they want to leverage a code repository, pipeline control, to kind of get them through the life cycle. But you have to have that similar tool set. But I feel like at some degree, the cybersecurity, CSPs are going to provide more of the resources, and it's kind of really building this platform on top of them. We'll see how it goes in a couple of years here, but but I feel like this is a very innovative concept. But I would look at the DoD Enterprise DevSecOps design. So lastly, how are we on time here?
We're good. We started 10 minutes late, so you have another 10 minutes.
Okay, cool. So I'm just going to show you guys two things real quick, and then we'll follow up here. So, all right. So one of the things I just wanted to show you is, we built a site out here. This is that tiny URL stuff. So if you go here, there's a checklist, and there's some resources that will actually go through some of the things that we talked about today. So there's the pricing calculator. There's some of the impact level services in scope. There's some of the important Azure and AWS documentation, and we have some stuff on best practices.
So if you remember that URL that I showed at the very beginning, this is that site that you can get to after the session, but you're always like, oh, I should have asked this question, or oh, I wish I got that URL. Everything we're talked about today is on this site. So as long as you got that little URL, which we'll show again, and at the end, so you have that, so you can have access to this. And this is up live. We're not pulling it down.
Cool. Yeah, always like to make that available. So, so here's an example of Security Center here. So if you can see that, this is one of my demo environments. So, it basically gives you an at-a-glance view of all the great things that are happening within this environment. So if I pull up Security Center, so you can see, hey, it's doing regulatory compliance against, these controls. As I mentioned, there's the CIS benchmarks. Some of my resources need some security hygiene because I see a lot of red, which is probably bad, right? So there's some really, really cool stuff there. The other thing is, from an advisor perspective, it'll advise you on some of the security performance. One of the other things that I would mention is like from a multi-factor security. So probably one of the first things that you ever want to do is ensure that your users have multi-factor authentication on. Passwords aren't just enough, so we need to make sure that we apply those. And even I mentioned automation and orchestration. There's some really cool, they have automation playbooks built in that you can actually apply to your environment. So you can get pretty sophisticated with coding some really cool stuff. And then from a management, over on the AWS side, they have a management console, and there, there's loads of stuff. And if you go over, they have a security hub. And, if you look at the console, I feel like Azure's is a little bit more complex. I think AWS is getting there. But I think Azure released theirs in 2016. I think AWS released theirs in 2019. So, it's the never-ending cloud battle. But, as you can see, there's a lot of findings that I need to fix, and you can see they're doing some of the CIS overlays. So I would definitely recommend looking into those CIS benchmarks, and I can show you that. So so back to the finalized thing here. Sure.
So Matt, I have a question about accountability in a cloud solution. If there is a data breach, who's responsible? Is it the cloud provider? Is it the system integrator?
Yes.
Is it the DoD organization? Who's accountable?
So most of the time it's the mission owner, right? So, and if there's a breach in the CSP, you're probably not going to hear about it per se, because that's, I want to say that goes up through the FedRAMP or whatever, and most of the time it's probably an issue with the mission owner. So normally, if you have a cybersecurity service provider or a CSSP, you're going to work with them and the mission owner to help remediate that. Question?
After this one's big stuff, I guess, but talking about mission owners, and let's assume what I can take back to my commander. Going to cloud services is outsourcing, right? Right now, the commander, when they're talking about their mission, they own it. They can set their assets the way they want. Right now, I'm going back to my commander going, oh, we want to outsource all this stuff. How do I assure him his mission is going to stay flexible? I love you guys' presentation, but I'm having a real hard time coming up with a so what today.
So I think if I could put in the simple elevator pitch, it helps streamline capability quickly. Like, so, you don't have to worry about building this entire infrastructure. It's there, it's available, you spool it, and you can easily inherit those capabilities. If that makes sense.
I mean, it really boils down to scalability, because you have finite resources sitting in your data center today. And if something happens and what happens if you got to expand? You got to go procure more hardware, more software. That takes time. In the cloud, it's there instantly. It's instant on. You hit it, it's there. But it's pay as you go. In your current data center, it's CapEx. You got so much budget. It's a shrinking budget, most likely. You can't always buy all the equipment you need. The cloud is an OpEx. And so it's up, you're powered on, you're spending money, you power it off, you're not spending money. So that's the biggest thing, is that scalability on demand when you need it. And sometimes that's the reason why the hybrid works so well, because there's certain workloads that you're going to run all the time. Keep them on-prem. But that demand, that surge and stuff, use the cloud.
So yeah, we're looking at a hybrid solution more, but again, it's kind of, again, defeats a lot of the purpose of what you're talking about there. That
Yeah.
instant scalability.
So I think it's sometimes harder if you look at it just infrastructure to infrastructure, but the reality is it's kind of all about these services, and I think we're moving to this kind of services type cloud economy, right? So you may have some really cool AI tools, and you can quickly consume it in the cloud. So I want to say, like, as we drive into the future, we're going to see hundreds of services probably at different accreditations, and it basically now I don't have to build the service from scratch. It's just available to start using. So the idea is, as a mission owner, you can focus on the mission and not building infrastructure and building functions and building applications, because it should be there.
The cost benefits actually when you move up the stack. When you're at infrastructure, it's just like having in their data center. It's when you move up to platform and software as a service is where you get the thing. Because think about it, if I'm running database as a service in the cloud, I don't have to worry about the patching of the database. I don't have to worry about patching of the OS. I just have to worry about the schema and the data flowing in and out and the right applications hitting it. Then I can free up that admin that was worrying about patching to do something else. So you're getting that capability that you don't get today in your legacy data center.
Cool. Alrighty. So to finalize this, I always like to end with, if I look at some of the mature cloud cyber operations out there, in order to defend against threats, there's kind of 4 areas that I think are important. The first thing is, you have to know what you have. You can't defend what you don't know you have, right? It's that shadow IT aspect. And you have to build resilience early. I think cloud is a true enabler for that. They help you build resilience, and because all your assets are there, you know what you have. The second piece is you have to kind of really standardize on what your cyber tools are. 150 tools doesn't necessarily help, right? So what are those core foundational tools that are part of your CSP monitoring? Third thing is automation. So the more that we can integrate, the more that we can automate, the better it is for our cyber ops. And then lastly, you have to have skilled cyber teams. And I feel like having some core, Azure expertise and AWS and Oracle and Google is important. The important thing is adversaries thrive in complexity. So the more complex that you make these environments, the much harder it is for it to be secured, as well as it makes it easier for our adversary to break in. So that being said, we Tuesday, November 19th, that is today, from 6:30 to 9:30, we're throwing a great party. So make sure you take a note of that. Come by our booth. You're all invited. And me and Neil, thank you for coming to our session.
Go back to the slide, show the URL. The URL.
Oh, yeah.
The agenda slide.
Cool.
But yeah, thanks for coming. We'll stick around for a little while if you got any questions. We'll also be at the booth if you want to come by, have a deeper conversation. Happy to do that. So, and like I said, thank you for attending. Have a great day. Have a great conference. And it was great to see this many people show up on the first session. So,
Awesome.
no, go back to the slide 2.
Hey, thanks, guys.
Yep, thank you.
Nice presentation.